address the evolving needs of California's water system due to climate change and other factors, the Delta Conveyance Project will modernize the water transport infrastructure in the Delta by adding new facilities to divert water and upgrade the current conveyance system to include an underground tunnel. Presently, water flows through a series of natural and man-made channels and canals through the Delta and then to the State Water Project. However, the infrastructure that moves this water through the Delta is outdated and at risk of failure due to climate change, sea level rise, and seismic activity. The Delta Conveyance Project will help mitigate these threats by allowing the flexibility to capture water from the extreme weather events that are becoming more common. The conveyance system would safely divert water that would ultimately be used by the 27 million Californians and 750,000 acres of farmland that depend on the State Water Project to reliably provide clean and affordable drinking and irrigation water. The Delta Conveyance Project will transport fresh water 47.5 miles from the North Delta near the community of Hood to the Bethany Reservoir and existing State Water Project facilities. The conveyance system will consist of 2 new water intake facilities along the Sacramento River, each with a capacity of 3,000 cubic feet per second, and cylindrical T-screens to protect aquatic species while feeding water into the conveyance system. These intake structures allow the diversion of water from the Sacramento River and represent the most upstream facilities of the project. The intake structures would be climate resilient, designed to accommodate 200-year flood levels and sea level conditions expected in the year 2100. Including the training walls that connect to the existing levees, each of the intake structures would be over 1,400 feet long. Each intake would include an on-bank intake structure and ancillary facilities such as sedimentation basins, gates, and electrical infrastructure. Boring the tunnel for this project is a huge undertaking. 2 dual launch shafts will be constructed, where large tunnel boring machines will be assembled and lowered into the ground to begin the tunneling. Each of these launch shafts will serve as the starting point for 2 separate TBMs, one traveling north and one traveling south. These machines are capable of boring an approximately 40-foot diameter excavation required to construct a concrete-lined tunnel with an inside diameter of 36 feet. TBMs can remove 3,050 tons of material per day. Over the course of a year, TBMs can typically excavate 2 miles or roughly 40 feet per day. A TBM of this size has an equivalent height of a 4-story building. In total, over 18 million cubic yards of material from ground improvements or tunneling operations would be handled over the course of construction. Referred to as reusable tunnel material, this material will be reused for other construction needs such as levee repairs and access roads. However, not all of the RTM would be needed during construction, so some of the material would be permanently stockpiled. Once boring is complete, the site of the launch shaft will be downsized to a smaller, permanent site footprint. Land reclamation efforts would allow some of the former shaft sites to be returned to agricultural land uses after construction. There will also be 6 maintenance shafts along the tunnel every 4 to 6 miles, 3 reception shafts from which the tunnel boring machines will be retrieved after boring has been completed, and other ancillary facilities to support construction and operation, including access roads, concrete batch plants, park and ride facilities, and power infrastructure. At the south end of the main tunnel would be the Bethany complex, which would consist of the Bethany Reservoir pumping plant and surge basin, as well as a host of ancillary facilities. The focal point of the complex is the pumping plant, which will pump water directly into Bethany Reservoir through a series of parallel 15-foot, 2.5-mile-long pipelines referred to as the Bethany Aqueduct. The southern end of the tunnel would terminate at a reception shaft within the Bethany complex, which would be converted to a surge basin capable of temporarily storing water if needed. The pumping plant would be designed to pump up to 6,000 cubic feet per second of water uphill through the Bethany Reservoir Aqueduct to the Bethany Reservoir, located approximately 200 feet above the pumping plant. The aqueduct would primarily consist of 4 buried above-ground 15-foot diameter tunnels. However, portions of the aqueduct would be tunneled to avoid impacts to conservation easements along the route. Once water has flowed through the aqueduct, it will enter Bethany Reservoir through a new discharge structure. The Bethany Reservoir discharge structure would be located on the eastern bank of Bethany Reservoir at an elevation of 227 feet. The 4 15-foot diameter pipelines comprising the Bethany Aqueduct would terminate at this structure through tunnel reception shafts. and flow through 50-foot maximum width channels that convey water directly into the reservoir. With the project finished, water can be safely captured in the North Delta when available and transported over 47 miles to the Bethany Reservoir, which serves as the headwaters to the California Aqueduct, where it will be conveyed for use in the rest of the State Water Project. The Delta Conveyance Project is one important strategy California is pursuing to increase the climate resilience and reliability of this valuable resource.